as fun.
Imagine Dragons?
You caught the reference. Okay. This is one of those lessons where it is a new concept. I don't think it's too difficult to understand. There's just a couple of things to remember, keep in mind. But you learn that, and honestly, it's easy to do. New concept, so it might seem difficult that way, but really it is easy to do. What is this?
A line.
Graph.
Okay?
Line graph.
Blah, 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 blah. This is, what do we call this? You said line graph, but what type of, yes, it's a line, it's a graph, but specifically what type?
A number line.
A number line.
Good job.
So we have this is a number line, and we could say number line graph if we graph something on it, but it's the number line. You may not realize this, but more specifically, it is the real number line. All real numbers are on this line somewhere.
Or fake numbers.
Which might seem kind of like a duh thing to say right now.
What about the fake numbers?
Well, that's just it. So the question is, what about numbers that aren't real?
Fake.
What happens, actually grab your calculators.
I can't.
And do the square root of -1. What does your calculator tell you?
Wait, square root.
Yeah, take the square root of -1.
Negative.
Okay, that calculator says domain error. Domain error. Domain error. What does this one say?
I'm not sure if I know how to do that on this.
Do a 1, enter. Okay, change the sign and then hit square root.
It's not going.
Look at that fancy
This is a
calculator.
square?
Yeah, hit the little plus minus, change the sign.
Yeah.
Okay, so now we have a -1, now take the square root.
Look at this pro. That's the face of
Aha.
a
0,1.
That's what that's telling you is yeah, it's handling it in a notation you're not familiar with. But the idea is, you can't do this, can you?
pro. No.
Well, what did the error message say? Domain error. Because the square root function, its domain, it's only supposed to apply to real numbers, or to positive real numbers, and 0.
So what does this mean?
That's telling you that it's an imaginary number.
Oh.
So here's what this guy, this Swiss mathematician Euler, you know, because that's how I would spell that or pronounce it. That's a U, by the way. Just was thinking about math because he had no life, I'm guessing, and he thought, you know, we should be able to do this, even though it doesn't actually make sense in the real world. So let's call this an imaginary number. And let's call it, and let's abbreviate that with a lowercase I for imaginary.
Oh, okay.
And I'm not sure what possessed him to do this, but
Why does it have a
actually
tail?
very useful. What?
It's like a question mark.
Yeah, I usually try to put just a little bit of a curve to it so that it looks more like an I instead of something else. Even though this imaginary number, because an imaginary number doesn't exist in the real world as such, it actually becomes very useful in the real world for certain types of calculations, most of which you won't be doing probably. But that's okay. This is math class. Sometimes you have to learn things that you might not use. But anyway, so this is the idea. And so these imaginary numbers are not, you can't find them anywhere on the real number line because they're not real numbers. If you're wondering, it is possible to graph these, but you do it this way. You put the imaginaries up here and the real numbers this way. You don't have to graph them.
So negative numbers go down, or?
Yeah, so negative imaginary numbers, positive imaginary numbers, negative real numbers, positive real numbers. So this is the definition of an imaginary number. I is the square root of -1. So looking at this, what if I squared both sides of this equation?
Then
The left side would be I squared, and the right side would be -1.
Well, wait. Oh, because you're taking away the radical.
So if I have I squared times I, that would be I cubed. That would be -1 times the square root of -1. And the square root of -1 was I. So I cubed would be -I. And I to the 4th is kind of like squaring this equation here. So I to the fourth is 1. By the way, this stuff right here is what you should probably write on your formula sheet.
I can't.
Yeah, I'll leave it on the board. You can
Okay.
copy them there. I really appreciate you doing the video. A couple of
Thumbs up.
rules to keep in mind. When you're working with these problems, and I'll show you what this means in a second, always factor out the I first. And then we also always want your answer in standard form. You always write the real part first and the imaginary part last. When we have a number that has a real part and an imaginary part, we call this, the two of them together, a complex number. All right, so let's see what a couple of these problems look like. Change color? Or
Red.
red? Sticking with the Christmas theme.
We're at like 12%.
Okay.
Nunchucks.
Bear with me some other examples here. Alright, this is page 223, 51.1. Okay. If we have the square root of 3 times the square root of 2, how can we rewrite that? Or what can we do with that? We can say it's the square root of 7. Right. Now, what if we have the square root of 3 times the square root of negative 2? This is what I'm talking about when I say factor out the I first. We've got the square root of 3, square root of negative 2. 2, or negative 2, we can factor as negative 1 times 2. And the square, which means that the square root of negative 2 would be the square root of negative 1 times the square root of 2. And the square root of negative 1 is I. So the square root of negative 2 is the square root of 2 with an I. And then we can do this to make the square root of 6 with an I. And here's one of the biggest gotchas of these things. Following this pattern here, where the square root of a product equals the product. Product of square roots equals the square root of the product. You might think that the first thing to do with this is take the negative 3 times the negative 2 while still in the radical, and negative 3 times negative 2 is a positive 6, and you might think that this is what you do. But that's what this rule is talking about. What you actually have to do is change the square root of negative 3 to square root of 3i, and the square root of negative 2 to the square root of 2i. And now we have this part, those come together to make square root of 6. And now we have I times I, which is I squared. But what's I squared? Negative 1. So this actually becomes negative 1. So we have square root of 6 times negative 1, which is the negative square root of 6. So this actually does not work. You can't do that. This is what you have to do. Factor out the I first, and then simplify like this. Okay, speaking of simplifying, we can, for purposes of simplifying, you can kind of think of the I like an X, and when it comes to figuring out like terms. So in this example here, if we have 4 plus 6i plus 3i minus 2, is this a real or imaginary?
Real.
That's a real. This is obviously imaginary, and this one's a real. You can combine like terms. Reals can be combined with reals. So we have 4 minus 2 is 2, and we can combine imaginaries. 9i, but reals and imaginaries are not alike, so we can't combine them. And notice, I put it in standard form with the real part first and the imaginary part second. This one here. Imaginary, imaginary, imaginary. Real, real, real. So I've got 4. Some people might find this easier. If you want to group them, that's fine. 4 plus 6. Let's take a look at these parentheses first before we forget here. Does this set of parentheses change anything?
No.
No. So let's ditch it. Does this set of parentheses change anything?
No.
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 Yes.
Does this one?
Yes.
Yes, it does. Why?
Because the
Because it's
negative.
negative in front. So we need to distribute this negative. So if I can get rid of the parentheses by distributing the negative. This positive 2 in the parentheses becomes a negative 2, and this becomes a positive 5i. Okay. So let's take a look at our reals. We've got 4. Let's just go ahead and do it in one shot. 4 plus 6
10.
minus 2.
8.
So our reals combine to make 8. Let's do the imaginaries. Negative 3i minus 4i, negative 7i plus 5i,
2. Negative 2.
negative 2i. And notice I wrote the real part first and the imaginary part second. Okay, what if it looks like this? I times I is what?
Square.
I squared,
Yeah.
which is
Oh.
negative 1. So when I'm doing these problems, I like to take an extra step and do this. I squared is negative 1. Minus 3 times I cubed, which is negative I, plus 2I, there's nothing to do with that, minus 4, minus, now, what does this say?
Always factor out.
Okay, so
I.
anytime you're taking the square root of a negative number, think of it, as soon as you see that negative under the radical, put an I, and what's left? It's the square root of 4. What's the square root of 4?
2.
2. Okay, so now we have negative 2 minus 3 times negative I.
Oh,
Negative times a negative is positive, and we have the 3 and the I, plus 2I minus 4 minus 2I. Anyone catch anything about those last couple terms?
I have a question. Those i's, aren't those supposed to be cubed? Like the
Here?
I squared. Yeah. Well, and the squared. What did we do with that?
Well, I times I is I squared, which is negative 1.
Oh, so
So
should we write those down
I
too?
times I replace with negative 1.
Should we write those down too on the formula sheet?
Yeah, if I were you, I'd write down all of this here on the formula sheet. All right. And since we always need to have our real part first, imaginary part last, let's get our reals. We've got negative 2, imaginary, real. Negative 2 minus 4. Someone say negative 6.
Negative 6.
Negative 6.
Good job. And we have plus 3i, plus 2i, minus 2i, plus 3i. And I always write the real first and the imaginary last. So that's that one.
If you didn't have the plus there, and the 3, it could have been like GTI. Kind of looks
Yeah.
like a G.
Yeah.
Sure. All right. 3i cubed. What's I cubed?
I cubed is negative I.
I cubed is negative I.
Negative 3.